Well, good afternoon, everyone. We really appreciate the opportunity to talk with you. Thanks for stopping by for today's presentation. My name is Eric Woldridge. I'm professor here at Somerset Community College and the director of the Additive Manufacturing Center of Excellence for the KCTCS system. And today's topic is something that we are very passionate about. The way it'll kind of go, we'll present some of the materials, some of what we did, things that are coming down the pipeline. And we'll save the last 10 to 15 minutes for a question and answer session. Again, if you're joining us, please do us a favor and mute your microphones, and then we can turn them on at the end for our Q&A. Just right off the bat, again, very excited to talk with you all in the middle of the continuation of COVID. Our title today, of course, is the COVID-19 Solutions and What Happens Next. And I'm going to be using the term additive manufacturing interchangeably with 3D printing. If you're used to one versus the other, that doesn't really matter. They're essentially the same term, but depending on who we're talking to, sometimes we switch back and forth. The key thing is that 3D printing is a newer technology, a younger technology, and the impact of COVID had a real opportunity for it to shine out. I am going to kind of make the assumption that everyone who's joining us today has a feel for 3D printing and has an understanding of it, at least a basic understanding. You may or may not have your own equipment in your labs or at home, but if that's not the case, we will have some resources at the end of the presentation that you can go back through and kind of get a feel as an introduction of what 3D printing, additive manufacturing are. But let's go ahead and get started with the big term, COVID. COVID is now the answer to everything. If you missed a meeting, you can say COVID. If you can't get a table at a restaurant, COVID's the answer to that. In my case, if you can't get a haircut very often, COVID. You know, it's our new normal. And from a standpoint of how it's impacted us, we've always seen a bunch of maps. We've seen hot spots. We've seen changes and that sort of thing. And I'm using this graphic to just reiterate what COVID is doing, where the hotspots are, but also to point something very, very specific out to what we're talking about today. And that is the supply chain breakdown. And if you look at the map, you know, we see where a lot of our stuff originally comes from. You go buy a television, electronic device, furniture for that matter, manufactured here, and it would make its way right across the screen to the other side, to California, and then be distributed over to Kentucky. So this is how we got things. This is how a lot of the world was getting things. And there's a lot that goes on between here and here. And that's often what we refer to as the supply chain. And what happened during COVID? Well, not only did people stop going to work, manufacturers shut down, transportation slowed, supplies were rejected, sometimes put into quarantine, and we essentially saw the breakdown of the manufacturing supply chain that we had come to appreciate and consider commonplace in our daily lives. And it was pretty easy for it to break down. You know, the supply chain is actually a very, very fragile thing. I love to quote him on this. I've got a buddy, his name's Justin Leach, and he's an executive for John Deere. He spent about 3 or 4 years actually over in China in their manufacturing facilities. And we were talking a couple years ago about the supply chain risk, and he made the comment, he said, you know what, it's a miracle that things even get made nowadays. He said, when you consider all of the players, all of the partners to get a product out there, all the way from pulling material out of the earth to processing it, to getting it to one vendor, to the next vendor, and to finally a subassembly and putting it on a ship and getting it somewhere, it's just a flat miracle. But it's a miracle that's a chain. And you break one link in that chain and the whole chain becomes useless, which is exactly what we saw, especially when it comes to things produced for PPE, personal protective equipment. You know, COVID starts breaking out, and you see hospitals starting to fill up. You see workers being exposed. They don't have face shields. They don't have gloves. They have dwindling numbers of face masks. And their exposure puts them at risk and puts their patients at risk. And so the PPE was probably the first thing that we really recognized as a major failure in the supply chain. Now, our manufacturing supply chain up to that point had been great. You know, we had this whole lean manufacturing. We had just-in-time delivery. We didn't have a lot of stockpiling, a lot of inventory. Everything seemed to be great until this happened, and suddenly we're starting to reconsider the validity of that approach. And so as the supply chain broke down, we needed a fix. We needed something to hack the supply chain. We needed a stopgap solution. Some way to come in and actually turn around and produce what we needed, even though our entire system had collapsed. And that is where we talk about today, or what we talk about today, 3D printing. In that moment, all of these do-it-yourselfers, folks that had 3D printers in their basement, teachers, companies that had banks of 3D print farms, you know, in tens and hundreds, stepped up to the plate and said, we can help. We know you can't make what you need to have, but we can 3D print it for you. And so you saw the rise of additive manufacturing into the mainstream spotlight, because even though everything else was shut down, people could still 3D print. And why did it work so well, or why is it so able to step in that way? And it's for a variety of reasons. When you 3D print, a single operator can run 30, 40, 50 machines by themselves. So it reduces your actual potential contamination or spread. 3D printers typically work off a condensed material supply, like a roll of filament or a bag of powder, maybe a canister of resin. So you can actually take a condensed amount of material, put it in a printer, and get a lot of products. A lot of printers operate on multi-ranges. We can do plastics, carbon fibers, soft materials, flexible materials, you know, glow-in-the-dark materials, materials that change shape. So these 3D printers that are out there have the ability to print in a lot of different types of stuff that we need. And when you want to take a printer and print one part, no problem. You want to print 2 parts, you want to do batch production, no problem. You want to do 4, 8, or even 10 or 20, no problem. In fact, you don't have an issue with having to like shut the printer down, take it apart, retool, or have downtime associated with printing one part and then another. If I want to do a face shield, I can. If I want to do a face mask right after that, I can. If I want to print them together, I can. So this ability to pivot and do product pivoting and without any tooling or downtime, that is a tremendous difference from conventional manufacturing. So that's why Additive was able to step in and start with face shields. One of the very first things that we saw being mass produced as a result of the supply chain breakdown was the face shield. A company called Prusa Research over in the Czech Republic. Now, some of you may actually have Prusa printers, which are very, very popular. They step up to the plate and say, all right, we're going to divert our 500 plus 3D printer bank, and we're going to start producing face shields. And what we're going to do is we're going to design the face shields ourselves so that they are optimized for 3D printing. We're going to put videos on how to put them together, and we're going to share our files with the world. So not only are we going to do it, but we're going to make it possible for everyone else to do it. And from that, you know, thousands upon thousands upon thousands of face shields were produced worldwide because of that initiative. And that was the first thing. But then that got people thinking, what else could we do with a 3D printer in the midst of all this? Could I make something that someone else needs? Can I come up with a new solution that no one else has seen before? It unleashed the potential of the technology because people saw it as the thing that could keep going when the supply chain broke down. So, case in point, hospital over in Spain doesn't have these respirator valves. Can't get them anymore, and obviously these are critical to human life in the middle of COVID. So a company pops up and says, you know what, give us one, we'll make a model of it, and we'll print you what you need. We can do about 100 in 24 hours. That makes a huge difference. And so it was one of the early ones that we saw, especially over in Europe, is that kind of movement. And that just spurred on other ideas. Somebody else said, hey, you need a stethoscope? We can print that for you. We can use these printers that we have right on our desks to make these products. Another company steps up during a little bit later on in the outbreak here in America. Form Labs, they divert 250 of their printers up in Ohio to start producing the swab test kits, or the test swabs. They can do about 100,000 a day using their printers. And this was actually a pretty interesting process because we were actually a little privy to some of it because we were considering it for Kentucky production as well. And it was a quick turnaround. You know, we just had to have the right material, resin, and the design, and it was ready to go. It was no problem to actually fire up and start participating in this process if folks wanted to. And it just shows the power and how quickly it was for somebody to step in and come up with a solution just because they had a 3D printer and knew what to do with it. Ventilators. You know, this is basically the device that keeps the oxygen flowing one way, your carbon dioxide flowing the other way. And the DoD did this. They actually came up with this nifty little ventilator system, totally 3D printed. And so successful, they even make the comment, so, you know, when this pandemic's over, which who knows if that'll happen or not, but when it's over, we might be able to use these in the field. They printed so easy, they're so portable, and the size is so easy to use. This is great. And then, of course, the face masks. All kinds of 3D printed face masks are out there at this point in time, whatever style you like. Kind that are just basically a ring that fits over a cloth. The kind that actually are very, very complex with lots of parts that are medically approved. You know, maybe not necessarily N95, but really close. The kind that are actually more simple. The kind that use adapters that are already out there to make it fit around your face. You know, limitless possibilities in terms of the face mask. One of the projects that we're working on with UK right now is also a 3D printed face mask, but we're going to use nano coating, or UK is going to apply nano coating over top of some of the components, some of those discs that you see there on the bottom left, so that it'll actually kill any microbe, any virus going in or out. And so these 3D printed masks can be completely reusable, washable, and we can even incorporate them into our HVAC systems to purify the air. So amazing technology simply because the 3D printer will, if you understand how to use it, it'll do what you need. Oxygen masks were made. We saw, hospitals starting to realize they could 3D print parts that they normally had to buy, couldn't find any anymore. And so if you just had a printer, you could actually make the part if you understand what you're doing. Companies would step up and say, well, we're going to divert some of our more industrial 3D printers to assist in this too. This HP multi-fusion jet fusion, is an amazing system. Super, super fast, super precise. You know, they could take one and actually make 50 to 70 face shield or face masks in one run. And it creates more of this mentality of like, we can support with what we have. GM, same story. You know, they point out almost overnight they were able to switch over their additive group and start producing, 17,000 face shields. And it made the comment, we could not have responded to the coronavirus as quickly as we did without 3D printing. Aside from the face shields, they actually 3D printed the tools to help manufacture the ventilators they were supposed to make. And then simple solutions. You don't want to actually touch the handle of a door. Materialize came up with a design. They put it out there for free that you could put a bracket, print a bracket off, screw it together up top your door handle, use your forearm. You won't even go that far. You want to use your foot to open a door. There's several versions of a foot gripper that you can buy, screw into the base of your door, and open your door with your foot. Handy innovations, ready to go. All you have to have is a 3D printer. And not even that great of a 3D printer. Most of this work can be done on what we consider a low-cost printer. Stuff that's a little bit nifty, maybe a little bit more trinketish, but still a neat idea. You want to keep your hand sanitizer from being contaminated by your hands, you can have a wrist brace that adds it to it. At least people are creating solutions simply because the printer can make it for them. A little bit more complex. Ventilators and respirators themselves are typically very complex, commercially made products, tens of thousands of dollars just for one. And so there became obviously the need to find a lower cost option. And fortunately for Spain, in Barcelona is where actually one of HP's 3D printing headquarters are. So they team up and they came up with a 3D printed respirator, medically improved 3D printed respirator. And you can see the parts on the screen there. They're actually really good looking parts, and that's because the HP system is actually a very, very good printer. But you can actually have a commercial product ready to go, developed in a matter of days or weeks, and ready to go out there and save lives. And then you can just start producing it as soon as it's ready. Want to go a little bigger? Winston over in China was 3D printing, and probably still is, 3D printing quarantine booths for Chinese hospitals to reduce the overload. Basically prefabricated little booths where people can actually stay in quarantine, and they're actually printed in concrete, which typically is about 3 times stronger than a typical concrete wall. So you're seeing just opportunity after opportunity after opportunity. As far as SCC, what did we do? Well, our story kind of goes like this. We were already in the process of, we've been expanding 3D printing across the state, doing the courses, the curriculum, and that sort of thing. We had just come off spring break when the semi-shutdown sort of happened. We had about 3 days where we were planning on bringing students back, and then by Wednesday, it was pretty much said that we're going to have to switch everything online. They're not coming back. At that same time, we were seeing the impact over in Europe. We were seeing that the situation was pretty bad. The supply chain breakdown had occurred, and we were getting requests already to join in the worldwide contribution of 3D printing, PPE, and also parts that they needed for equipment, and sending them to Europe. And so we kind of reported on that Wednesday, reported into administration and say, you know what, this is probably going to get bad. We're probably going to need to prepare our labs for production to assist in this process, and because it's coming. We saw the signs. At that time, we weren't getting authorization, so we did have to shut down the lab for the Thursday and Friday. But then Monday came. The governor's office contacted KCTCS and said, what can you do? We got together, and by that afternoon, that evening, we got approval to go back in the lab. I showed back up about 4:30 in the morning the next morning with my stuff to spend the next few nights. And we started producing about 5 or 6 o'clock, and had some designs rolling off the printers by 9 o'clock that morning. Some prototypes to get us going. And over that course in time, so we started essentially about mid-March and kind of started shutting down around early May once things had caught up a little bit. And during that time, we produced about 7,000 face shields, around 1,000 ear savers, the typical little types that go around the back side of your mask, the face shields, being a very simple design in essence. So about 7,000 of those were produced utilizing a 24-hour production cycle and a very skeleton crew. So they ran every day of the week. Generally, it was just me. I stayed here in the lab, for that time, and I'd have one lab tech come in the morning, one in the evening to kind of assist in the process. So Matthew Sizemore and Heather Beebe came in and just, made all of this possible. We had another volunteer who would come by in the evenings, and he would actually pick up the equipment and take it with him to work on it at home and bring it back. So minimum staff, but we were able to produce a lot of product. Overall process was fairly straightforward. We fired up a lot of printers and produced a lot of parts. Did our own maintenance and just kept going and going and going. So over those weeks, we learned a lot, a tremendous amount about 3D printing in general and what it's like to actually use a print farm to do scalable production. Some of those lessons are what we're here to talk about today. And going forward, things that we learned from this experience and how to incorporate them later on. For one thing, low-cost production. For the majority of all the production that we did during that time, we used 3D printers that were generally $230 or $420. Now, everything, for the most part, was under $500 for the majority. So we like to use low-cost printers because we can operate them ourselves. It doesn't take a lot of effort. We can keep them maintained ourselves. And your price point to run them is much, much lower. Material costs and those kind of things. So low-cost production, or high-volume low-cost production, is really where it's at. We also wanted to focus on doing batching versus singles. Now, we worked with a different group statewide, and a lot of people had different mentalities on how to do these face shields. And that was our primary mandate. So on the left there, you see a picture of one of the smaller headbands that were used in the face shield design. And the face shield essentially is 3 major parts. You have some type of headband, you have some type of transparent material, and then an elastic band to keep it around. So one version of the bands is the small one. You see that people liked it because it could actually print very quickly. The problem in that scenario, what we saw was like you can actually see glue on that image to begin with to hold it down, but also a human being has to come in there and swap out the part and restart every time that printer gets done. Another variation is to actually print several on the build plate at once, which is good, that's batching, but you're still dealing with downtime every time it finishes. The route we went and learned is the highest production is to go batch printing but with vertical stacking. So the parts are actually designed to sit one on top of the other. And the process overall means that the designer has to be on top of their game, understand the technology well enough, but by producing vertically, you reduce the amount of downtime. And at the end, production cycling, what you have to understand is that production value drops every time you stop the printer. So by going vertically, we were able to run the printer longer with more parts and with less stops. And that's essentially what we're telling folks. If you're going to go for scaling, that's where you want to be. That's your sweet spot, maximum vertical. Some folks will even run these things up 16 units tall. So we also had multiple sets of production cycles. So if we wanted to do a number of headbands over an 8-hour period, we would set it up for 8 hours so that we were coming in a normal 8-hour workday and then cycling back off. Then we have the same headbands with a larger number set for 16 hours. And then we have another set for even larger number for about 23 hours. So that way we had a production cycle type for the weekend, so one person could come in over the weekend once and reset and go per day. Then you had a nighttime cycle, and then of course you had your regular day cycle. So that production cycling was key to us being able to produce a larger quantity with minimum effort. Because again, a well laid out production cycle, one person can easily run 30 to 40 printers and keep them cycling if they plan it out. Another thing that was interesting during the process that we learned, and that was the need to say no. So, and this is actually kind of counterintuitive to 3D printing, because normally with 3D printing we talk about how, with 3D printing you can improve something continuously. If you have a better design, boom, you can do it one day and your product is completely updated and everyone from there on out is new and updated, which is great. But in our case, since our mandate was to produce as many of these face shields as possible, we had to stop and say no to a lot. I would get emails once people kind of saw some of the news articles and those kind of things and say, hey, are you doing this face shield type? Are you doing this face mask? Have you tried this new design? And there was lots of new designs. What we had to do is turn around and say, no, our mandate is to keep producing in the higher volume, because every time we stop to actually implement a new design, that reset everything and create a new learning curve to have to work with. Now, we did make some changes. You see on the bottom left, that red one was one of the earlier headband designs from Prusa, and it had the polygon holes in it, and they didn't print very well. So actually, the simpler version on the right is the one we finally went with over for the longest period of time. So saying no to optimization sometimes is necessary in volume production. You have to keep the main thing the main thing. But then a problem that had really nothing to do with the 3D printing, and it's just the reality of the situation. One of the major hurdles, in fact, the 3D printing of all the parts that we needed was actually pretty easy when you look at it. The problem was the logistics and the manpower. For example, this face shield requires a transparent material. Well, all the plexiglass was gone. I mean, just gone. We called everywhere. So we had to switch to using overhead transparencies, which essentially meant that although I would get permission, I was crawling around in people's offices at night trying to find old stockpiles of transparencies in closets and everything. We found a lot, but it ran out quickly. Even the elastic bands were running out very, very quickly. So we had just the raw material issues. That was actually solved through social media. So we would put out a broadcast across Facebook and social media and say, hey, we're doing this, but we need overhead transparencies. We actually put a box outside our door that you can see right there, and people would come by at night and drop off elastic bands, transparencies, whatever they could find to help us out, and just do that as a community support of what we were doing. So the social media aspect sort of took care of a lot. We also had donating, or had great companies that came alongside. Jamel Industries of Jamestown came alongside and donated like thousands upon thousands of elastic band to actually make the face shields. And then Danville Office Supply also kicked in and donated a lot of transparencies and helped people who wanted to support buy the transparencies at cost and deliver it right to the door. So that helped a great deal in terms of that format. But the other problem was simply manpower issues. You know, we can print these all day long, but someone has to take the transparency and add it and to tie on the headband. And we were only allowed to have one person in a lab at a time doing this for quarantine. At the end of the day, a person at their absolute best may be able to get 60, 70 a day, you know, and their hands are hurting by the end of that day. And we were just totally limited. We couldn't produce. We were out producing significantly. We had some folks that would take like kits home and put them together. But the real solution came when groups volunteered to actually get together and do a full assembly. So the Kentucky Extension Agency allowed some of their staff in our region to meet 1 day a week and get together and just assemble face shields. So we would take everything to them, like on Monday morning, come back on Tuesday, 1,000 face shields would have been assembled. So those are some of the unsung heroes of the situation, and also issues that a person has to think about in doing this kind of work. You know, the manpower is going to happen at some point in time unless you can design in minimum number of parts into your design, which is part of the 3D printing advantage. The end result of all that, though, all that work and all that time and, you know, hours sleeping in the lab, was pretty powerful. Not only were we able to produce so many of these things, but we were able to actually make a difference. We gave them away to fire departments, police departments, Department of Defense, hospitals, a lot of nursing homes. And to be perfectly honest with you, sometimes we would have cases where people would actually be in tears when they received a box of these things because they felt it made them feel a little bit safer. And in those moments, it was really, really worth it to use the power of this technology to what we had been building for the last 7 years across the state to actually see it make this kind of a difference and making people feel safe and protecting lives. So a lot of hard work, but really something that was extremely rewarding. And 3D printing in general provided an opportunity for anyone to join in and help. It didn't matter who you were, where you were. We actually had a cloud site where people could go and get the same files we were using and the settings and the tutorials that we prepared and join in and help for their own community, or they could send it to us and we will get them shipped out. And so what you actually saw were a lot of kids who had 3D printers at their home. Maybe they got together with a few folks at school or something and went into a lab, and they were able to assist by 3D printing the ear savers, the face shields, the things that were making people at least more comfortable, and in some cases saving lives. And it was a powerful, powerful thing to see that happen. To be empowered where they can actually do something that really makes a difference. It's very exciting times. But after all of that, so we go through this, and the whole world's going through this. We're seeing what 3D printing is doing. You start to see articles that look like this. People start to comment. Researchers start to look at 3D printing and the broken supply chain. The digital supply chain reckoning. You know, what happens now? Now that we have seen what 3D printing can do, and now it's mainstream, and now we've seen how it is not really affected by the normal things that our supply chain is affected by. What do we do next? And of course, that creates a whole new horizon for additive. Companies have now woken up to the fact that this technology can eliminate a lot of problems they didn't even realize they had. You know, and one way of saying it is like, now that the genie's out of the bottle, so to speak, what happens next? Well, we start to see the signs when you start to see things like policy and procedure changes. When you start to see the entities like ISO, ASTM start to make processes for 3D printing specifically. One thing that we saw early on was the NIH, the FDA, and American Makes get together and they come up with a streamlined way, a streamlined approval process for 3D printing of medical PPE type of products. So therefore, there's a need, there's a solution with additive, And now there's a process for the FDA, NIH to accelerate the approval process, so it's not talking years, it could be talking just weeks, and then that company can start 3D printing, or the whole world, for that matter, could start 3D printing the solution as long as they follow the standards. And we saw an opportunity, quite a few of those opportunities realized during that process. Another entity, the ASTM, where we get a lot of our standards for manufacturing, they have their international standards now for 3D printing, design, production, and testing of PPE. So now we have a pathway to accelerate the production, the process, the approval, and get more products into the field that are trustworthy and ready to go. So those standards have changed, those policies have changed, which means that companies and entities are making some bigger additive manufacturing moves. Case in point, the French Army. After seeing this huge supply chain breakdown, what do? They go out and buy a ton of printers to set up their own print farm, so they don't have to worry about supply chain breakdown for a lot of their parts. They can just make them themselves. You know, they see the weakness, they see the fragile nature of the supply chain, and so their solution, we'll just make it ourselves. And to be perfectly honest, an investment like this to actually set up a print farm is not that big compared to military spending. You look at the Air Force, Space Force, you know, the head of the acquisition for the Air Force, he says 3D printing is going like gangbusters. They've seen the weakness in the supply chain and how that affects combat readiness. In fact, there's some that point out that America's biggest weakness in terms of combat strategy is the supply chain, not the actual combat itself. It's the ability to get what we need is so fragile. This is our biggest threat to national security. And so not only they're already printing parts that are going on planes and helicopters, they're starting to print parts for satellites and propulsion. And it just keeps growing and growing. Even the Army had a nice little project to start 3D printing customized hearing or earplugs to reduce the risks of hearing damage, which can affect combat readiness. And in terms of medical, another major recent breakthrough that we just want to talk about is the fact that another heart has been 3D printed, an actual working heart pump that is made from real human cells. You can Google this anytime you want to. It's easy to find. It's one of the first times we've seen video of the actual heart pump working instead of an animation. And they also have a time lapse on there of literally this little thing being printed by the machine. It's really awesome to watch and just realize that's human cells being turned into a working heart pump. Pretty crazy. You can also look at companies that are already in the manufacturing field that see this opportunity and see the writing on the wall. Henkel, for example, they employ 55,000 people worldwide, manufacturing facility, and now they are expanding their additive. So if you have a supply chain breakdown, you call Henkel and say, I need this product, I need this produced. They'll scale up and print it for you. If you have a new idea for a product, new innovation, you go to them, and so you can avoid the whole supply chain issue and months of planning and coordinating to get something made. Now you can actually just have it 3D printed. You look at smaller companies. Havatech is actually a company that makes machines that do agricultural product sorting, and they were affected by the supply chain breakdown. So now what they've done is just gone out and buy some industrial printers, and they're just making their own parts. Now they don't have to worry about the supply chain. It's actually saving them money in the long run. They have complete control of their process, and even the parts look like real conventional parts. You know, these systems are so fast and so good, it's hard sometimes to make the distinction. And so not only are they saving time and saving, you know, basically protecting themselves from risk, they're also saving a lot of money. BMW is another company to look at. This is their third big announcement. A couple of years ago, they announced their $10 million expansion for additive production facility. Now they're throwing another $19.5 million at it to expand it even more so they can go more and more additive production. They see additive as the way to go, and they want to 3D print as much as they can for their vehicles. Recent surveys coming out. This one actually was done by Mark Forge. They surveyed a bunch of manufacturers. You have your general manufacturing, your automotive folks, product development. And you see the chart on the right is the really one to pay attention to because you see a huge flip. 2 years ago, we saw the inverse. Yeah, there was prototyping with 3D printing. Yeah, there was tools and fixtures. There's maintenance. But now companies are focused on in-use, consumer-ready products that are 3D printed. That's a major, major jump. And it's a sign of the times because they see the advantage that this offers. Look at your federal spending. Louisiana just got another $20 million to be spread across 5 to 6 universities and no telling how many schools to advance some of the material science associated with 3D printing and to teach additive manufacturing in their colleges and schools. The overall goal, get this technology into the hands of our people and let them use it to innovate and create new things. Let's not have the supply chain problem when everybody knows how to 3D print and they know how to 3D print correctly. And then this one, very, very recent, pretty exciting. 3D printed ovaries. The ability, this test has actually already been successful. They have 3D printed ovaries, put them in a mouse, and that mouse has successfully given birth to healthy offspring. Just think about the impact of that and what that can mean for so many folks. And this is just another case, another leap of this technology in doing something that is just, almost sci-fi in nature. So yeah, mice have been born through 3D printed ovaries. The Army really loves the idea of using low-cost 3D printers to produce things in combat zones. Then although they have the high-end equipment, they like the low-cost equipment because the low-cost equipment is a lot easier to print with, maintain, and put into a combat zone. The problem with the low-cost equipment is the material. The material wasn't super strong, so they come up with their own material. A new type of material that's actually a combination of existing stuff. They do an apples-to-apples comparison with a 3D printed version of a part alongside a typical ABS plastic part that's injection molded, and the 3D printed part with the new material is 15 times tougher than the conventional injection molded part. And that, of course, is incredibly telling. And so that filament, you can use it with any printer. So that means that a roll of filament can now make the difference between a part that's battle ready or not battle ready. So material is part of the game too. We actually see this also. Benvic has actually come up with a new line of PLA, for those familiar with that term, a new plastic that prevents bacteria from growing on any kind of surface. So they're rolling out this plastic so you can print with your printer and you can be making medical tools and products that won't have microbial growth. So it's very much a materials game to go with all these printers that we have out there. So after all of that, thinking all this through, seeing what's happening out there, what happened during COVID, what may happen again. We're almost out of our supply of face shields that we stockpiled, so we may have to fire back up and produce more. What are we doing now to advance Kentucky in additive manufacturing? One of the things that we had planned is this: our mobile A&P project, funded by the National Science Foundation ATE program. This trailer that you see was going to be loaded full of advanced 3D printing equipment, computers. It was going to come right to your site, spend a day or two with you doing advanced 3D printing, advanced design, scalable production mentality, training in all the real stuff to move away from the keychains and trinkets and start doing the things that really, really matter. But then COVID happened. And so we were not allowed to do face-to-face training at this point in time. So that project is being put on hold. We do anticipate that we will be given the green light eventually, but right now it's held in place. So some point in time, we're going to get approval. We're going to come to locations all across Kentucky and start bringing the advanced equipment, 3D printing and advanced materials and doing this training, but we just have to wait a little longer. And we'll talk about how we'll announce that kind of thing a little bit later on. But what did come out of COVID that was pretty awesome is this new project referred to as RAMI, the Rapid Response Additive Manufacturing Initiative, based on what we did during COVID and the ability to pivot and create a whole new product line and step in for the supply chain breakdown. We were federally funded to actually start creating 4 to 6 new sites across Kentucky to mimic our own, be capable of doing the higher volume production like we are, and also to be ready to support the supply chain during breakdown. Part of the deal is that each one of these sites, and these will actually be KCCS community colleges in many of your areas, they will also be offering our 3D printing certificate. So students can actually get a certificate in additive manufacturing and get the advanced skill sets that are needed. And they will also be required to offer more dual credit courses so that high school students can start getting in on this early with the advanced skills and the additive manufacturing focus that's making all the difference. Now, the RAMI is also designed to actually be a real world solution. So we will test that solution every so often. So once these sites are set up, we will do simulations once or twice a year where we'll come up with a scenario of like, hey, this product has been stopped due to pandemic, natural disaster, terrorism. We can't get it. We need it. RAMI network, we need you to take this design, fire up, and produce it in the next 16 hours, and let's send them all to one site. A demonstration of cloud manufacturing and how cloud manufacturing can actually solve problems when well coordinated. It'll be kind of the first of its kind. People have talked about it, but no one's actually done it, and no one's done it on a statewide scale. So we're going to be the first ones to actually demonstrate that this is a viable production methodology. So we're very excited about that because that's going to mean a huge difference for every region that gets one of these sites, and in terms of training and also what can be done. And RAMI comes with one additional thing. A relatively new breakthrough that we actually had right before COVID, and because of COVID, we had to kind of like put it down on the back burner. But we now have the ability to 3D print in metal using low-cost equipment. Typically, if you wanted to do a 3D printer in metal, you actually had to go buy a $100,000 piece of equipment, safety training, and that kind of thing. Now, there's a way to do it with low-cost desktop 3D printers. What you see right there at the top of the screen, that's all stainless steel. You can see the tensile test dog bone in the middle where we've kind of like poked at it and ground off the surface to see the surface finish. Full-on 316L stainless steel and produced on a 3D printer that costs less than $600. Technically, the printer costs about $450, do $150 worth of upgrades, and you've got a legitimate metal printer. No safety requirements, no safety features necessary, no safety training. You don't, aside from COVID, you don't even have to wear a face mask. But you can actually be producing metal printed parts in your labs with a desktop printer, which we see this as a huge opportunity for Kentucky to be the first that's doing this all across the state, that students have exposure to metal printing and are producing real metal products, and not just stainless steel. You can also do this in tool steel, titanium. The materials just keep coming out. But it is an opportunity like no other. And furthermore, we were actually the first in the world to test the weldability of these parts. So we took some of the parts that we 3D printed on these $600 printers, welded them together, and the bottom piece that you see there is actually 3 pieces welded together, and you can see how good the welds were. Now, granted, we have a really good welding instructor, one on the top, Carl Watson. Many of you know him. So he's really, really good, but the process works. We've actually seen some really favorable properties associated with the welds in terms of these part performance. So we're 3D printing stainless steel on a $600 printer. It's weldable, it's workable, and has some unique material associated properties with it. So this is a huge deal for Kentucky, and it's a huge opportunity for us to expand our workforce and be one of the only workforce states in the nation that everyone knows how to do metal 3D printing and are doing it on a low-cost basis. So we're very, very excited about that. Along with that excitement, coming up, we will be releasing the information on which sites will be selected as RAMI sites across the state, that 4 to 6. We're still not sure exactly on the budgets how many we're going to be able to get. But we'll be making an announcement later on this fall in terms of who is going to be RAMI. And also we'll be making announcements as soon as we get the green light on when the mobile A&P training will begin going across the state and actually setting up these workshops to do advanced 3D printing on site. Along that note, if you are kind of new to 3D printing or if you want some resources, you can always check out our YouTube channel, the Additive Guru. That's actually where we put out a lot of our materials and videos and equipment training and that kind of thing. So make sure to check that out. It's also good. We have news briefs on there for if your student information, if you want to use those for just like updates. And to kind of finish up, I'll just add the slide right here. This is all of our social media. We do most of our announcements straight to Facebook and then push it out to our other social media. So if you friend us on Facebook, you'll actually be able to see which sites are selected for the RAMI. You will actually be able to see when the mobile A&P is going to start, when workshops are. We use social media as our way of getting it out there. You can also, connect to me on LinkedIn, where we'll do some publications. A little bit more of the research side goes on there, and of course Twitter. And if you want to see our webpage, you just have to Google SCC 3D printing, and it'll take you right to our webpage. We're usually like the first one after the ads. So what I'm going to do is actually leave this slide up so you can take a screen capture. I guess you can hold your phone up to the camera if you want, or the screen if you want to, and connect with us that way. But at this point in time, I'd like to take the next 13 minutes and open the floor for questions. And let's just talk 3D printing. What can I answer for you all, and in terms of what's going to happen and what you need to know? Make sure to unmute your mics in that moment.
Eric, it's Reagan. You have a question in the chat box. Carl has asked, can you give details on the affordable printers?
All right. What we are saying right now, yes and no. Printers themselves can be bought off Amazon, but there are specific upgrades they have to make them work correctly. So we're not ready to release that information out until we get the RAMI set up, and so that it's easily replicated. But that information is coming. I just don't want to say it right now, otherwise you tried, and if we don't have it dialed in fully for you, then you won't be able to make it happen. So apologize for that, but it is coming.
And then Casey has their hand up. So
okay. See if I can get it to work.
Eric, this is Casey. I was kind of the same question. I was wanting a suggestion on an affordable printer to buy for my lab at school.
Sure. As far as like just the regular printers, not the metal ones right now, but just we have a lot of success with the artillery sidewinders. The artillery sidewinder X1 can be found right on Amazon, and we have a lot of success with the Ender 3 Pros. To support those particular choices, we actually have on our YouTube channel some tutorials showing how to put those together and get them dialed in. We also have a lot of success with the Prusa research printers, the Mark IIIs and those kind of things. So any one of those three are good buys. We have a lot of Enders just simply because we can easily work on them and get them dialed in. We do love the artillery sidewinders though, because they have a lot of features and they're really good bang for their buck. But you can definitely check it out on YouTube to see like how to put them together and how we use them.
What's going on, you guys? Over Jesse here.
All right, so let's see. I'm going through the send a PDA search, guys. Suggestion on resin printers. So there's a wide variety. We actually have the Formlabs in here, which is a little bit higher dollar. That's $4,000 or $5,000 investment. It does a really, really good job. We train a lot though with the lower cost resin printers. The Igloo Mars is one that we use a lot of. It's on Amazon, 230 bucks, and it's enough to get the job done in terms of training. It teaches them the safety of handling the resin and just the overall logic of it. It doesn't have a very big bill volume, but for the most part, resin printers, for training purposes, you don't really need big volume. The Moai from Matter Hackers is another one that we have. A little bit higher volume, a little bit higher cost. But to start folks off, I would go with the low cost, the Igloo Mars off of Amazon, and that'll do you just fine to get going. Anybody have any questions like on the automotive side of things or that kind of thing? We're actually about to present in late August at the Kentucky Association for Manufacturers. And what's really interesting this year, so we've done it before, but there's been like 1 or 2 sessions that may have involved additive manufacturing 3D printing. This year, if you actually look at their itinerary for the 2 or 3 days, roughly about half of the presentations and presenters will be talking about 3D printing. So we're seeing a complete flip in terms of manufacturing mentality, and a lot of those are automotive. You know, and the word supply chain is seen in there time and time and time again. So there's a big mental shift that's happening, and directly here in Kentucky about this. So definitely recommend that if you all have time, because it's going to be virtual too. I'm not sure what the costs are going to be to sign up, but it ought to be a very good conference and really informative about what's coming down the pipeline and what these companies are going to be looking for. Another thing that we often run into in conversations is what software to use. We highly recommend using Fusion 360 because, for one thing, it's free. And right now, Fusion is really pushing the envelope in terms of 3D printing connectivity, meaning that their design software is getting very well aligned with how additive can use it very, very well. And you know, as long as you have good internet, it's a pretty good option. So definitely check that out. We actually have a lot of tutorials on our YouTube channel using Fusion as well, if you're not.
Eric,
Yes.
this is Dolores Rice, and I'm going to teach the intro.
Dolores.
How are you?
I'm good.
Good. I'm going to teach the intro to 3D printing technology this fall.
Okay.
Do you think the Igloo Mars is what we should get for our classroom for those students?
So if that being a resin printer, that's what I would get for the resin printer side. For FDM side, what do you all use for your typical plastic printing?
The only thing we have right now is the Stratasys.
Okay. Yeah, I would get maybe an Ender 3 Pro or 2 in the lab. And they're low cost, $200, $230, and I would get a couple of those for your typical FFF plastic 3D printing. And then I'd have one Igloo Mars or something over on the side as your resin printing demonstration. Because you got to teach them all, and you know, you don't want to run that Stratasys very often because it's expensive, but you can run those Enders and the Mars all day long and keep that cost down.
Okay, great. Thank you very much.
Welcome. Carl, yes, you are correct. Fusion did open their generative design to the educational community, which is amazing. If you're not familiar with what generative is where all design is going. That's a whole different topic, but what it boils down to, so as an engineer, if I want to design a product, I generally come up with an idea in my mind and I CAD it up. Generative works in opposite. Instead of me designing anything, I design the situation. So if I need like a bracket to hold two things together, I'll design a cylinder and a cylinder, and I'll say it's going to have like 300 pounds of force here, and this one's going to be held in place. Software, you tell me what I need in the middle. And it will generally give me, it'll take material choices into account, and it'll give me 60 options, 10, 15 minutes. There's no way I could have ever come up with that. And that's actually why you're starting to see more of these products out there starting to look like they're organic, almost like they're bone or they're organically structured. It's because generative's in the background creating these products, and the engineers and the designers, they're just kind of confirming. They're just double checking things. But generative is where everything's going because it combines design, artificial intelligence, and finite element analysis into one. If you are interested in learning more about that, one of the courses that we offer is called DPT 150, and it specifically teaches generative design and also lattice structure design, which is another way to optimize, where we can take products and actually reduce them down by lattice structure, which we found to be very, very effective. Actually, if you want to, on our webpage, we have some free samples. So at the very bottom of our webpage is like a blue button that takes you to our cloud drive. And we have these donuts that you can download that we make, and they're super, super strong. And here's one. They are designed to help people understand the power of additive by making these complex parts that are almost hollow and yet super, super strong. It'll take about 400 pounds of force to break this little donut, and it's made out of the cheapest plastic out there. So you can download those, but lattice structure design in topology, that's all part of DPT 150. So we are definitely encouraging as much fusion use because of they're giving away that kind of technology. That's what's going to get more innovation.
A question about the technologies for the hemp fiber that is used in automotive for door panels, interior door panels, and what have you.
Yep.
Is additive manufacturing used in that manner as far as generating that shape? Can they take that fiber and turn that into where they can spray that and use that?
They are. In fact, there's a slide that I didn't include just for time on here. There's actually been a pretty strong movement. Again, I go back to the fact that now that we have these 3D printers, everybody's creating these new materials. And there's actually a lot of movement toward hemp-based super strong material. So I can go out right now and buy rolls of filament that are hemp reinforced, and I can print with them right now. So that is definitely on the market. And the fact that I can take the hemp and then design a product that is the perfect design to utilize that hemp and utilize that structure is really where this is going. 3D printing allows this exotic material to be combined with these exotic shapes to be the perfect solution.
Yeah, the strength in the wire and the hemp fiber is incredible, really.
It is incredible. I mean, now don't get me wrong, we can do carbon fiber, fiberglass, and those kind of things too. But the hemp is going to be an amazing material to produce with.
Cost effective, yeah.
Yeah, absolutely. So, and that's the best part. Here we have these $400 printers all over our lab, and they can use these, super exotic, high-end materials. You look at your big chemical companies; they're coming up with all kinds of exotic materials to use on these desktop model printers, and that's very telling because you can get this machine that's producing advanced stuff for less than $500. Let's see. Is there a state-approved reseller for Filament that you would suggest? Okay. So we generally, and of course I don't know purchasing processes for everybody, but we actually can purchase through Amazon, and we do get a lot through there. However, another filament supplier that shouldn't have any problem, and we actually put them into our system without too much of a problem, was Matter Hackers. They're over in California, and they sell a lot of exotic filaments that you can utilize. There's several resellers. There's the Ultimate 3D Printing Store down in Florida that you can probably add in. That can be vendors as well. It kind of depends on your particular situation. We didn't have any problem getting them as a vendor. There was just a simple form. But Amazon's probably where we buy most of our lower cost filaments from, and the others are where we buy the more exotic stuff. One of the things that we avoid typically is package deals. Any printers that require their own proprietary filaments, like you can only buy stuff from them, we avoid that because it's usually telling in terms of like what the printer life is going to be like. I make the example of MakerBot. MakerBot started off as an open source situation, and we could do a lot of things with it. Then it got bought out, and then it had some bad years there. Don't get me wrong, we have MakerBot, and they do some great stuff. But we have kind of like shied away a little bit from anybody that is producing something that we have to use their stuff for. Advancing this technology needs to be an open box approach, and plus you need to be able to work on it yourself and to keep it going and understand how to repair and keep going. So that's why we're definitely all about the lower cost equipment that's pretty basic. All right, so looks like Reagan has to hop. Okay. All right, so looks like our time is up. Thank you again, Reagan, for putting this all together and getting the recording done for us. I appreciate everyone for your attention. Go check out our social media, friend us on Facebook and LinkedIn, and any way that we can help, let us know. We look forward to hopefully connecting with you once the RAMI initiative is out there, and we're doing more of this, especially on that metal printing. So thank you all. And I hope you have a great afternoon.
So you'll be sending us our time for our PD?
That will actually come from Reagan.
That'll come from Reagan. She's got record of that. Thank you so much. That's a great. I really enjoyed this.
Excellent. Well, we're here all the time. You can watch me all the time on YouTube. We'll see y'all.
Right. Thank you.
Bye-bye.